Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Friederike Ernst, and I'm here with Meher Roy. And today we're speaking with Sebastian Bürgel, who is the founder of HOPR, which is a mixnet that we'll talk about in just a second. But before we talk with Sebastian about HOPR, let me tell you about our sponsor this week. Our sponsor is Tallyho, which is redefining the wallet as a public good. You can think of it like a community-owned alternative to MetaMask. It offers a very smooth user experience and has an impressive user interface. So you can see all your account balances at once and swap between assets within the wallet at a much lower price. It also offers a very good ledger integration and full ENS and UNS domain name support. 2 weeks ago, they launched their community pledge with 70,000 signers dedicating their commitment to defending Web3. And you can still sign the pledge on their site. They recently also added their first sidechain, Polygon, and you can enter the metaverse with a Web3 wallet that's fully community owned and operated, and it's also a DAO. And they have demonstrated their commitment to community ownership and public goods by sponsoring Ether.js and pledging 2.5% of their total token supply to a Gitcoin aqueduct. Head to tally.cash/download to redefine your Web3 wallet experience. And also, we as Epicenter are hiring, so we're looking for a community manager to help grow our audience and take Epicenter to the next level. So if you're passionate about crypto and creating great content, please let us know and contact us. And full details can be found in the show notes. And please feel free to share this job description with anyone who you think might be a good fit for this position. Sebastian, it's a great pleasure to have you on.
It's absolutely a pleasure to be on my favorite crypto podcast, to be here. Thank you for having me.
Fantastic. Sebastian, can you give us a little bit of background about yourself? What happened before blockchain? I read you went to ETH Zurich.
Yeah, so basically, first of all, the university that I did most of my degrees in is called ETH Zurich. For the ones who haven't heard, it has indeed nothing to do with Ethereum. It's been around for over 100 years before Ethereum existed. But yes, it's a funny thing. So yeah, my life prior to joining the crypto movement was actually in microtechnology. So I did a PhD here at ETH Zurich, focusing on using microfabrication and microtechnologies for biomedical applications. It's a pretty exciting thing to do. I had a great project there, but unfortunately then the crypto bug had stung me. And I decided that I would first need to take some unpaid vacation before I realized, okay, I have to go all in. There's no way I can stay in this old academia world. I had co-funded a fintech startup here in Switzerland and had a little bit feeling for what permissioned innovation actually means and how cumbersome it actually is if you want to build something novel in the old school banking world. So, I'm very much a believer in permissionless innovation after the experience that I made there. And yeah, so then had to again pivot more towards crypto. So I co-funded a blockchain education and service company called Validity Labs, where I worked for a little over 4 years full-time in educating people on public blockchains and working on tokenization projects from startups to like large corporates and Swiss banks. And it was there that we realized that there's really a missing link in the technology stack that builds up this Web3. And that's, I guess, what we'll talk about in a little bit. And that was kind of the discovery period of founding HOPR.
Okay, so in a nutshell, what does HOPR set out to do?
Yeah, so fundamentally, any sort of crypto application needs to send data across the wire somewhere, right? So for any sort of application that you can think about, you need to send digital data from A to B. And it might be, your Bitcoin transaction, which you send from your Bitcoin wallet to some node, which might be your own or might be a hosted provider. It might be, if you think about something totally outside of financial transactions, maybe we're talking about something like Filecoin, right? Where you want to query and access data, or maybe we're thinking about the graph, right? To access on-chain information. You always have this setting where you need to send data from A to B. And that data is kind of, typically it's secure, right? It's end-to-end encrypted. So I cannot change the data, and I cannot impersonate you usually, but it's usually not private. And that's what we set out to change. So if Friederike is requesting data from any Web 2 or Web 3 service, she is kind of inherently also broadcasting her IP address. And third parties can see things such as where she is when she requested the data, how often she requested data, and like how big these data packets are. So even with end-to-end encryption, there's a whole lot of metadata that all sorts of third parties, not just like these evil kind of three-letter agencies that we're always thinking about, see, but also, more obvious things such as your internet service provider and other for-profit organizations, they can see that data and use it against you. So HOPR sets out to solve transport privacy for the web and Web3.
So, I mean, like stating this problem in a different way, like this problem has existed since the beginnings of the internet, right? So one way to maybe think about this issue is, even in a normal postal system, when let's say I'm sending a normal analog paper post to Friederike with a from, so there's a from address, which is my address, and a to address, which is Friederike's address, and it goes through the postal system and is going to touch the Swiss and German postal systems in this case. So anyone that is handling that envelope knows from and to, and he knows that pieces of data. And if Friederike and I communicate very frequently, well, they know that these two individuals write to each other every month, hence they are friends, or something like that can be gathered without reading any of our letters, and that the postal system can do. Now, shifting to the internet, it's exactly very similar, where it's the message is originating from my IP address, so that's the from, and it's going to another IP address, which is Friederike's, which is the to. The thing is, in the internet, I'm sending messages much more frequently than I'm sending physical envelopes. So I'm doing a lot more communication than we used to, like 30 years back, let's say. And then the other issue is that the people in the postal system, it's like the Swiss Post and the German Post that was handling the metadata, which is the from and to. But on the internet, the metadata might be handled by lots of different parties. And I might not know any of these parties, and these parties may not even be any kind of like sort of official organizations like the postal service at all, right?
Yeah, I think that's a great analogy. And to make it a little bit more drastic, there's this great meme going around Twitter every now and then, where people are actually, somebody was receiving not a letter, but actually a little packet. And this packet was unfortunately wrapped in kind of some shrink wrapping format. And to make matters worse, and to highlight why there's a privacy issues when you send stuff around, it was actually kind of a female sex toy, right? So that could be publicly seen and was probably very embarrassing to the person who received it. So yes, that's a great analogy. And so what HOPR does there, to take this analogy back to what we do at HOPR, is we're taking these packages, we're chopping them down into little pieces that look indistinguishable from one another, right? So you cannot see anymore, okay, Friederike is typically sending like these large envelopes. When she's sending like, some contractual agreement, she sent like some small things, which looks like a postcard for more personal stuff. So, and that sort of stuff is what we're chopping down in like little into like little things. And from these little elements, you cannot deduce anymore what was being sent, right? So that is the first step of how HOPR protects metadata better than traditional ways of sending stuff around on the internet.
Maybe it's a dumb question, but like many people would think that kind of the VPNs solve this issue, right? So many people start using a VPN when I think the normal experience is you want to watch a TV show and it's not allowed in your country, and so you download your VPN, and then the VPN service pretends as if you are in another country, and that seems to give some kind of confidence that hey, a VPN can protect where uh, my information is originating from. So aren't VPNs actually solutions to the problem of transport level privacy?
Yeah, so it depends what users want to achieve, right? If you just want to achieve that the operator of the website does not see where you're sitting right now, then, a VPN does a fair job of obfuscating that. But what's important to realize is you're fully trusting this one VPN operator with your entire browsing data, right? All apps that you're using on your phone, if you're connected from a phone, all websites that you're surfing, right? So they see all that information, and you're trusting a single entity. So the trust assumption of a VPN is that one server operator, their ISPs and all the infrastructure that they have around them, is trustworthy. And that trust is more often than not broken, right? We see kind of on an almost weekly basis how there's a new VPN logging incident, and these logs, so connection data logs, are actually accidentally becoming public knowledge to the wider internet. So, that's a pretty poor trust assumption.
Maybe let's talk about different kind of privacy preserving tools, just to kind of categorize them, at least mentally. So, I mean, we know there's other mixnets like NIM, and then there's decentralized VPNs like Orchid. Then there's onion routing, right? Like Tor. And then there's like these whisper protocols like Secure Scuttlebutt. And in a way, they're all privacy preserving. So maybe we can group them together. So how is a mixnet fundamentally different from an onion router?
Yeah. So first of all, when you talk about onion routing, maybe just as a recap for the listeners who might not be familiar with onion routing is very popular in a system that's called Tor. And many people here might have heard about Tor from the Tor browser, right? That you can access information privately. So what does it actually do, right? So onion routing is basically onion encrypting, so putting multiple shells of encryption around the payload that you send around, which is then sent through multiple hops in a network, and thereby obfuscating where data came from and where it goes to, right? So that's what an onion routing system like Tor actually does. Now, I mentioned before the trust assumption of a VPN being kind of poor. So now in such onion routing systems, typically your trust assumption is that the first and the last node are not colluding, right? So as you see data going into an kind of Tor-like network, and when it comes out, you can link the incoming and the outgoing traffic, and in relatively trivial ways can see, okay, this data is actually originating from Friederike, and she's requesting, this Wikipedia page, for example, right? Wikipedia actually has a Tor page, which is kind of useful. So yeah, that's significant step better than a VPN, but it's still not a very strong trust assumption that can be broken by multiple node operators in the network, and obviously strong, as we call them, global passive adversaries. So now moving on to the next category of mixnets, which have been specifically designed as tools that allow you to defend against these global passive adversaries, right? Like, again, the three-letter agencies and but not just three-letter agencies, but really also strong and big internet service providers and cloud operators, which have network-wide overview. So, and in this mixnet category, there's mixnets as an active field of research for a few decades. And in the mixnet category, like what is fundamentally new is that only since a few years it is possible to incentivize these mixnets, and that is something that mixnets like HOPR solve in a fairly unique way. That you can pay the operators of such a network without revealing their privacy. So that is something that is quite fundamentally different between mixnets and these incentivized mixnets, which we currently see like HOPR. And then you mentioned decentralized VPNs. So I think when was that? I think 2019 there were a bunch of DVPNs coming up. Orchid, as you mentioned, one of them. And the trust assumption of a DVPN is actually kind of problematic if you think about it. So the kind of like the motto of these DVPNs is, hey, let's decentralize the VPN operator. But what you're doing there is you're saying, hey, no, there's some person on the internet which is relaying traffic for me. And thereby, I'm trusting a rando on the internet with all my connection metadata, which indeed is not a very good trust assumption. Now, some of these DVPNs evolved and tried to make it a bit better. For example, Orchid recently introduced this multi-hop routing, which goes in a similar direction as Tor, in fact. So I think that is some breakdown of how some of these systems work. And again, it comes down to trust assumptions.
Is it correct to say that the fundamental difference between Tor and HOPR is that in HOPR you are able to add a layer of incentivization that doesn't exist in Tor, meaning in Tor when the message goes from A to B, it is going through a bunch of relay nodes and volunteers essentially run those relay nodes, which is why the number of relay nodes are very limited, maybe 6,000 or 7,000 of them. Whereas in HOPR, you are able to actually pay these nodes in the middle and therefore hopefully make a more scalable system.
Yeah, so that is one important difference is on the incentivization side. So you mentioned like there's a few thousand of these Tor nodes. Like the last, also called Tor exit node, there's actually under 1,400 nodes, right? So it's really not very, very big. And, Tor clearly has issues scaling to internet scale, despite having been around for over a decade. So, but the other important difference that we should briefly talk about is the packet mixing. So mixnets are called like that because they're not just forwarding packets as they hop through the network, but they're mixing them up. So imagine Meher is a mixed node operator. Meher will receive packets from Sebastian, he will receive packets from Friederike and a bunch of other people. Now Meher is doing two things as a mixed node operator. His node is obviously doing that for him automatically, right? So Meher is transforming packets so that incoming and outgoing packets look different. And he's mixing them up. So he's sending out packets after a short delay in a shuffled order. And by doing so, even a strong adversary that sees every packet going into Meher's computer and coming out of Meher's computer cannot link incoming and outgoing traffic. And this unlinking is a strong privacy property of mixed nodes specifically that Tor doesn't have. And it's one core differentiator between mixed nodes and traditional onion routers.
This requires a base level of volume, though, right? So basically, if you have, otherwise you're vulnerable to all kinds of attacks, right? I mean, so basically, if I just were to, if Meher only receives packets from me, then basically that would be absolutely no benefit in kind of mixing them up other than kind of adding latency.
Yes, that's absolutely an important point, right? So as people say, privacy loves company, right? When I'm alone, I sometimes bring this analogy. Imagine you're standing in this football stadium and you only hear one voice in the football stadium. And I know Meher is the only one standing in the football stadium. I know it was Meher who was shouting, right? But if there is, 50,000 people standing around Meher and I hear some noise, I have no idea if it was Meher who was shouting or any of the other 50,000 people. And the same thing applies to mixed nets. You do want a large number of users and a diverse set of users, right? I don't want to infer from any of these, packets which are being sent around this mixnet that, oh, now that was probably an Ethereum user, right? You want a large and diverse set of users. And the second thing that mixnets can provide, and which we are working on at HOPR, is so-called cover traffic. So effectively, we're providing this kind of background noise, right? So even if, you can say there's a party, but the party is not very busy yet. So we're having some background music that gives us a certain level of noise in the room already. Now, cover traffic is kind of bogus traffic, which is sent through the network, but which importantly is indistinguishable from real traffic in the network. And by having cover traffic in the network, you kind of solve a little bit the chicken and egg problem of how do you bring privacy to the early users of such mixnets. And yeah, that is something which several mixnets like HOPR use.
Okay, then maybe let's talk about the protocol itself. So maybe let's start in the beginning. So who is the actual HOPR user? Is it individual users, or do I as a dApp designer decide to use HOPR for my messaging layer?
Yeah, so it really depends. So ultimately, it's if you're using the internet today, right? You're typing in your browser maybe HTTPS, or nowadays you don't even type that anymore. You don't feel that under the hood, this HTTP protocol is using TCP/IP, right? So you don't really see or feel that, but you use it. And I can totally see the same thing happening on the Web3, that you will use HOPR behind the scenes, but so the first applications that we're kind of excited about is to bring privacy to Ethereum-based wallets, let's say a more private version of MetaMask, for example, right? So in such a setting, what I would hope for end of day is that you replace the transport mechanism between your wallet and the RPC provider. So that's typically providers such as Infura. Infura is like the default endpoint, which gives you access to the Ethereum blockchain. And I would see this entry point and exit point between your wallet and the RPC provider being HOPR. So you are a user, which doesn't necessarily mean that you need to pay for the service. Like we can talk about the business models that you can map onto such a system, which is quite diverse.
So in MetaMask, can I specify I want to connect to the Ethereum system via HOPR?
So not yet. Like we're working towards that, and actually we had a first kind of public UX hackathon with MetaMask just a week ago here in Zurich to think about like how would that even work, right? So how do you expose that to the user and go through exactly all these questions, right? Do I as a user need to make a conscious decision, and how do I configure it, and so on. So we're actively working with wallets towards that as we're building out the network. But no, HOPR is not having any active dApps that use it yet. However, if you want to play around with it, we have kind of a hosted version of the HOPR network. We call it HOPR Playground. So on playground.hoprnet.org, you can just at the click of a button, you will get a bunch of HOPR nodes that are being spun up for you, and you can use some applications that people are working on. So to give you some examples for some quirky first apps that people build is we have like a chat app, right? So something like Telegram, but much more private. Somebody has been working on a private version of chess. So, the chess world has recently seen some little scandals. And if you now don't want to disclose, where you're sitting or who you are and just want to play chess in peace, you can do that with HOPR, to give some examples.
Okay, so maybe let's pretend all of this already works for, say, MetaMask, or even their HOPR Playground. Say I play anonymous chess. So this somehow you kind of package my data up nicely. Obviously, it's encrypted. All packets are alike, as you said earlier. So where does my packet go first, and how does it know where to go?
Yeah. So effectively, as you send a packet out through the HOPR network, so the first thing to note is that the HOPR packets are source routed. So that means you decide which path the packet takes through this mixnet. And we think that is important because privacy is something that is inherently subjective, right? So what might be private and trustworthy to me might not be private and trustworthy to you. So, I as a user, or I at least as an application developer, have to be able to make these choices. So basically, you as a sender can decide which path this packet takes. Realistically, it's going to be your app, right? So your private version of MetaMask is going to determine a path, a multi-hop path through the HOPR network to the recipient. So then you will basically take this, let's say it's an RPC request, right? I want to know how much balance do I have? How many ETH do I have on my wallet? So that's being sent as a request through that network. Now, these packets, it might be that this doesn't fit into a single HOPR packet, but we need multiple. So data is either chopped down or padded to exactly the same size. And it's not just the data itself, but it's also the header of these packets. And the headers are needed to encode information such as like which are the hops, which are the HOPR addresses, as we call them, through which I want to route this information. But it also includes payment information. And all that is encoded in a header format, which is also privacy preserving. And there's people, luckily, who thought about this for quite a while and published a paper on that in that format that we and a bunch of others are using. Is called Sphinx. Sphinx is also used, for example, by Bitcoin Lightning Network. And it ensures that even in a packet header, you're not leaking information about who is passing data to whom. And yeah, so then this data packet is being sent to the first mix node. The first mix node is receiving the packet, is hopefully receiving also a bunch of other packets, transforming it. So basically taking this first onion shell, also in this mixnet, we're using onion encryption, taking one layer of encryption off, transforming the header, and passing it on to the next party. Now, specifically, we talked about at HOPR is it's incentivized. So what we do here is the incentivization scheme at HOPR is we want to prevent free rider problems. So we want to make sure that Meher, as a mixed node operator, only gets paid when he actually forwarded the packet. So the mechanism that we came up with for that is a key sharing mechanism. So Meher needs 2 keys in order to derive a payment. The first half is something that he can obtain from the packet header himself. And the second one, he needs to pass this packet to the next downstream node who will get back with the second key half. So let's say Meher is the first relay node and Friederike happens to be the second. So Friederike will get back to Meher, send him back this second key half, with which Meher can then determine if he, just received a payment. So yeah, that is the first step. I can maybe later on come to a second mechanism, but that's the first mechanism of the payment.
So just for clarification, so let's say like the user is sending to Infura a packet, and so Infura gets to select who these hops are. That Meher is a hop, so Friederike is a hop.
No, the sender of the packet gets to decide that. So the sender of the packet, which in my case, let's say I'm the user, my wallet or me myself as the sender gets to decide through which path I want to route this traffic.
Right. So in principle, because most users won't be technical enough to make these settings, it would be MetaMask that's writing the code for it, and that code will automatically select paths. So because in this payment scheme, when there are, let's say, 2 hops, and I'm one of the hops, and I get one key from the user, and I get one key from the next node, next hop, then you're assuming that me and the next hop are kind of uncorrelated or unrelated to each other. And so
Exactly.
this is something that the MetaMask code, which is picking these routes, will need to address by itself. And they are incentivized to address this because if things are correlated, then my packets could get stuck. So MetaMask will end up designing such routes that have uncorrelated hops.
Now, we make it sound kind of very complicated, but we basically have this path selection strategy that just does that for you. And the first one that we have implemented is just choose a random route, like choose a random hop at each step along the path. But yes, so you can change a different strategy, such as, for example, I want to avoid, any nodes in North America because I find them inherently untrustful. You can totally implement a strategy like that, right?
So, but that also means that the route that the packets are going to take is predetermined, and you don't need to generate randomness on chain, which is often a problem, right?
Yeah. So basically, I, as a sender, need to determine the path, so I can have a local random number generator, and we don't run into these issues. Now, there is a second interesting issue, though, and that is a naive implementation of HOPR would basically pay each of you mixnode operators immediately as you relay the packet. Now, the downside of that is we would leak the routing information on the payment layer, right? So let's say Meher is the first node that gets paid. He receives a payment immediately. And then Friederike is the second one, receives a payment immediately. That would leak a lot of information. Now, in order to hide that information, we're utilizing something that's called probabilistic micropayments, which was, for example, also used by Orchid, the DVPN system. So what happens here is that actually Meher, as the first mixnode operator, he derives one key half himself, gets the second key half from the next node, which is Friederike. And with these two keys together, he is basically generating a random number. And this random number cannot be spoofed by him. It cannot be spoofed by the sender. And this random number determines if this, we call it a ticket because it's a little bit like a lottery ticket, is a win or a draw. And when it was a win, he receives a payment, and otherwise, like, nothing happens. He cannot redeem a payment on chain. So in that fashion, we have effectively implemented something that works like payment channels. So we have payment channels here, which are probabilistic in nature, and you need to do a lot of work. So you need to forward a lot of packets in order to receive a payout for your service in HOPR. And it's a little bit similar if you want to say, how mining works, right? In proof of work in systems like Bitcoin, you need to mine a whole lot of blocks, and only after you did the job, you will find out, well, was this successful or not? So it's something that is incentivizing the most atomic operation of the network that provides utility. In our case, is not creating blocks, but forwarding packets.
So on the internet, packets are sometimes dropped, and I assume the same is true for HOPR. And I assume they will just be, basically, they will just be reset eventually. But what happens if I am a malicious node operator and I grieve the entire chain of people who've been sending packets on by dropping them consistently? Do you have any way of penalizing me?
Yeah, so eventually, like what we want in any of these kind of Web3 systems is that it shouldn't be attackable by exactly such attacks, right? So let's think about what would happen in a system like that where Friederike just consistently drops packets. So first of all, the sender, which is free to choose any route they wish, would determine that, hey, for some reason, all the packets that go via Friederike somehow never get anywhere, and just choose a different route. And secondly, on a more granular level, is the upstream node from you, which I stick to the example where Sebastian is sending something through Meher, who sends something to Friederike. The upstream node would realize, hey, okay, this downstream node never gets back to me with an acknowledgement of receiving the packet, so I never get a payment. So what would happen in such a system is Meher's machine would just close his payment channel to Friederike, and this edge in the network would effectively not exist anymore. So it would no longer be possible to relay data from Meher to Friederike. And ultimately, all nodes would do that so that the one who is misbehaving and not doing any work would not be able to relay traffic anymore.
And say I'm not malicious in the way of dropping packets, but say I'm a 3-letter agency and I kind of want to infiltrate the system. How many nodes would I need in order to kind of glean information about who's sending what to whom?
Yeah, that's a great question, and it comes back to the trust assumptions that I mentioned initially, right? So again, comparing this to a VPN, you need to operate this one server. If we look at Tor, you need to compromise the entry, the first node and the last node, the guard and the exit node. And in a mixnet like HOPR, you only need one honest mix node along a path. So if you have 3 hops and there's one honest mix node in the path and you compromise even both others, we're still fine. So that is pretty strong, and that's how HOPR can provide quite strong privacy guarantees. Like eventually, if the network gets too compromised, like you will accidentally route your traffic through only compromised nodes. Well, there's nothing we can do there anymore. But it makes it a lot stronger than in other systems.
Okay, and how many different, I assume one party can operate more than one node, right?
Yeah.
So how many different parties do you need to operate nodes? Or is it easy to tell which nodes are operated by the same party? Because basically if you send something along a path that has 3 different nodes and all 3 of them are secretly me, that's not helping you at all, right?
Correct, exactly. Now, this is actually, there it starts getting very interesting and kind of tricky, right? Because you could say, hey, we just KYC everyone, right? And there's like other systems that have proposed that. Like I'm strongly against such approaches because it goes against my fundamental value perception of the Web3 space. So the HOPR network is open and permissionless at all times, but the default path selection strategy that we implemented is selecting a path proportional to the stake that you have in the various payment channels that you have open. So what that means is if there's a party that is very strong, they would need to basically get an increasing number of stake in order to relay a significant amount of traffic via you. And even in that case, right, if it at some point becomes for whatever reason obvious that, Friederike is like subverting the entire network and has all these nodes, this path selection strategy can be very easily overridden and changed by something where, we just avoid the whale nodes or whatever happens to be the metric that identifies the subverted entities in the network.
So I am actually curious in terms of user experience. It feels obvious that as a user, I will need to pay to send the traffic, and these payments are additional to whatever I'm paying for my internet connection, right? So could you give us an idea of what is the quantum of these extra payments if I wanted to make all of my communications private? Like maybe we can assume a mobile connection first, where I might send 5 GB of data in a month. So
now, this is traditionally a very difficult question to answer. And by analogy, this is a little bit similar to asking somebody, well, you're coming up with this new blockchain, you're saying it's all scalable and great. Well, how much does it cost? And, giving an answer to that historically seems to haunt people. If we look at Vitalik, who says, sending a transaction that costs more than 5 cents counts as liveness failure. Well, that's kind of rough. In a very similar fashion, in the HOPR network, it is hard to estimate how much a packet is going to cost end of day. What I envision is it's going to be a dynamic pricing model. And here we get into an interesting domain where saying, when Sebastian wants to send something, he just sets a price point. Similarly, how on Ethereum you can determine your gas price, or in Bitcoin you determine what transaction fee you're willing to pay. But here's the problem. We want to establish privacy, and we want the anonymity set to be as large as possible. So you do not want Sebastian to set like a very unique price point of the data packets that he's sending, and Friederike like one that is very specific to her. because that would reveal who is currently using the network. So everybody needs to pay the same price at all times. However, and that part is forward-looking and not implemented yet, we do envision that there will be a dynamically upgradable price point of what these packets need to cost. Now, where that will be settled on a per kilobyte or per megabyte pricing, I have literally no idea where this is going to be in this dynamic network.
So if you compare this with Tor or VPN, that's a very different business model, right? So basically, I use a VPN and I pay like $10 a month or something to use it. So it's kind of a flat fee. Whereas I use Tor and it's free because it's operated by people who believe in the system, right? So do you think there is a subset of prospective users or applications that will kind of rely on this, and the bulk of our data that we send ends up unstripped of metadata?
Yeah, so I totally believe, first of all, that people will use that. And I would disagree that the business model needs to be very different. I can totally imagine that people spin a VPN-like business model where you pay your €10 a month, and for that you don't get like unlimited bandwidth like just in the VPN, but you can say you can use it like for, maybe 100 megabyte or whatever that you send through HOPR, right? So you come in and, pay with your credit card. You don't need to worry about any of this token business under the hood that is being abstracted away for you. When you download software, you download software that is not just normal VPN software, but it is software that utilizes HOPR and that contains a configuration for, how you get this corresponding HOPR tokens that you require to pay for the infrastructure. So I can totally see that you could spin such business models, or even Infura-like business models where the first, 200,000 requests or something you get for free, and afterwards you need to pay. So I do think that for HOPR and more generally Web3 models, we can spin existing business models that we're familiar with around them.
Okay, so maybe let's kind of segue into the HOPR token, right? So basically there's a HOPR token that is being used as a payment token.
Yes. So the HOPR token basically has these three functions of, as we already discussed, right? So as a mixed node operator, you need to stake that. I mean, when I say stake, it's like a gross simplification. What you're actually doing is you're opening these probabilistic payment channels to other nodes. By doing so, you're signaling, hey, I'm willing to relay data packets via Friederike. And secondly, I signal that I think Friederike is a useful mixed node that you should also relay your traffic by. And so the second part is the users are using the token to pay for it, right? So users pay the mixed node operators who are effectively infrastructure providers. And ultimately, the HOPR token will also be used for governance decisions in a network. And one that we already talked about is, well, how much should a single packet actually cost? And that is something that, currently in the current version of HOPR, we simply have that hard-coded. But ultimately, there will be a dynamic mechanism around that. And that is why I'm pretty interested in decentralized governance, because privacy networks should not be governed by one entity, by a handful of people, but by a more diverse set of people that have a say in this core infrastructure of what it does.
Okay, maybe kind of let's I want to dig my heels in here a bit. So I mean, the token function for governance and staking, I think these are really well validated token use cases. Whereas basically payment tokens, so far I would struggle to actually think about a single one that's really taken off, because usually it can be abstracted away, right? So basically it can be people can be made to pay in a token that they already have, and then maybe you have relay under the hood or something that kind of creates demand for that token. But why did you choose to go that way rather than just having people pay in, say, DAI or ETH?
Yeah. So, I mean, you could say, well, you could spin such a model in like the traditional argument is, why don't you just use Bitcoin for this, right? So that's the traditional argument that I get there. And well, one thing that would be kind of tricky to do in such a way is how do you scale the network with, for example, cover traffic? It is hard to do that if you do not control the inflationary supply of this token. So what we do at HOPR is we have reserved a comparatively large amount of the total supply of 25% for incentivizing cover traffic that provides the utility of privacy even for the early users or users when there's generally low utilization of the network. So I do see that as a mechanism. Controlling the inflationary supply of the utility of the network is something that is important and has to be closely coupled with the network itself. And yeah, that's why, I mean, you could say, okay, if we don't want any of that, or if you're anyway, have enough cash to incentivize this entire network, then, maybe you don't need any of that. I find it hard to argue how such a system would then remain credibly neutral, though. So maybe you could run such a system that's based off of ride or die, right? But keeping it credibly neutral would probably be hard.
So the argument here is that you want to bootstrap the early node providers, and the HOPR token is a way of getting early node providers into the network. I mean, like other networks have succeeded in doing something like this. Like Helium is a perfect example, right? Where distributing the early Helium rewards was the main reason why lots of people ended up installing the hardware in the first place. So that kind of makes sense. But still, like, is the reason for having HOPR a payment token more a regulatory reason that the Swiss regulators want kind of a payment-like utility for it not to be a security?
It's more the opposite, actually. For the Swiss regulator, like something that's not a payment token would be way easier because we wouldn't fall under harsh like AML regulations. So, payment tokens on that front only has downsides, actually.
Then why not just accept, I don't know, USDC? I mean, USDC, of course, the risk is they will put KYC on that system one day, but yeah, why not the US dollar or the
So
ETH?
the question is, in that case, how would you launch cover traffic? How would you launch kind of cover traffic that is not controlled by one party, which is kind of the donor to this whole exercise, and actually able to distribute traffic in a network that is indistinguishable from real traffic, right? So, I mean, to me, that is an important feature to be able to have something that's A, sustainable, and B, credibly neutral. And I think token models that have their own inflationary supply have shown to be something that can be sustainable. I mean, you mentioned Helium, but I think there's a bunch of others. And not stay under the control of a small group of people.
So maybe let's talk about the cover traffic then. So who actually who makes sure there is cover traffic? Is it you? And where are you sending all the stuff? And wouldn't it be thinkable to kind of have a traffic mining program akin to a liquidity mining program to kind of let the ecosystem do that for you?
Yeah, that's exactly actually on the roadmap. So there's two designs which we currently have. The first one, which is incredibly naive, is just we disperse a bunch of traffic to create some buzz around there, and we let you kind of start up some nodes, fire up some nodes, and get the network going. If you decentralize the problem, I like your analogy with this liquidity mining and traffic mining program. The problem there is that you don't want to Sybil that, right? You don't want Meher to start his node and create a bunch of bogus traffic that is only relayed via his own nodes, right? So that needs to be happening in a way that is actually trustworthy. Now, luckily, there are some technologies going in that direction of, for example, trusted execution environments and other multi-party compute schemes that allow us to decentralize that. So in the same way how it's now possible to like decentralize, even like I just recently heard about it, that decentralizing in a whole ETH staking node, you can certainly decentralize the disbursement of covered traffic in the network via. And the first one that we're going to try out is trusted execution environments, which allow you to do exactly that.
Very cool. As a maybe last topic regarding HOPR, before we kind of talk about the general privacy ecosystem, is the governance. So you have a new type of DAO that you have launched, right?
Yeah. So at HOPR, we do believe that decentralization and involvement of the community in decision-making processes is important. And to that end, we did already early on a bunch of governance experiments that we're very actively experimenting with. So I like to say that, when you go for a shared corporation, we have several hundred years of experimentation and blueprints that we can build on. I would say in the DAO space, we do not have that. We do not have any kind of, or very few kind of indications of best practices to follow. And that's why we did a bunch of experiments on actual decisions that we did in HOPR DAO. And that is, firstly, we experimented with like one account, one vote. We experimented with one token, one vote, and finally also with quadratic voting schemes. And for the ones who are not familiar with quadratic voting, just in a nutshell, it means that the more tokens I have, the more say I have, but the more tokens I want to buy, it gets quadratically more expensive to buy myself votes. And that is kind of a middle ground between kind of democracies, which typically have one person, one vote schemes, and like share corporations, which typically have $1, one vote. So all of that is something that we're actively experimenting with at HOPR in order to launch this privacy network, in a maximally resilient fashion.
And what is the current state of readiness of the HOPR software?
Yeah, so we have currently a network of 100 nodes online that is just about to launch in 2 weeks. We will replace the nodes that we run there with more community nodes, so people can participate in running a node. Initially, we have kind of artificially constricted the network size for 2 reasons. The first one is, we want this to launch in a stable fashion, and the second one is, it doesn't, like, the bandwidth requirements of the network is not so large that it would require like a huge network out there. It's kind of similar to the discussion around the security budget of L1 blockchains, where, in proof of work, for example, how much hash power do you actually require? Well, you just require so much that it's secure enough. And in our sense is we want to scale the network with the demand of applications that are being run on it. And that is the second side to it that we're very actively working on, that is working on apps that actually use HOPR. So I talked about some of the quirky ones that we have ongoing already right now. And we're specifically focusing on wallets. And we think that, wallets is our gateway to all of Web3. And they need to be significantly more private than they are today. So that is something we're working on, and this developer experience is ready to go. So if you want to build some apps, check out what's already been built, and check out the HOPR's Bounties program. So you find it at bounties.hoprnet.org. And if you want to build something that's not on there, just let us know, and we're happy to support you in building something that utilizes HOPR to build private applications.
When you say you think your gateway to all of Web3 is wallets, let's maybe be a little bit more specific here, because basically when we talk about privacy in wallets, people immediately think about shielded balances and kind of sending tokens in a privacy protected way to someone else. But that's not what HOPR does, right? So basically you would strip the metadata, but how much better would I be off if I used a wallet that stripped metadata?
Yeah, so you're absolutely right? Ultimately, what I'm always saying is we need full stack privacy. Even the most perfect on-chain private L1 or L2, right? And many great projects are working on that, right? So it's like Monero and Zcash, there's like Dusk, there's Secret Network, and there's AdStack and a bunch of others. So all of them, even if you have perfect on-chain privacy, that's not all, right? Because again, if you are interacting with any of these chains, you're sending a transaction from my wallet. I'm sending a transaction from my wallet, which can be observed at least by my internet service provider, which will know that I am, just accessing, let's say, AdStack, for example. And in that case, eventually there will be some observables. So I know there's some people working on privacy preserving DEXs, right? So, if you think about it, ultimately, there will be something that you can observe of the DEX, for example, the price, right? You always want to observe the price of a pool on a DEX, even if it's privacy respecting. Now I see that Friederike came online, she made some transaction. I don't see anything that she did there because it's a private L1 or L2. Afterwards, I see that the price was moving way up, right? Then Friederike is offline, I don't see anything of her. Now she's coming online again and the price goes way down. So what I'm saying is, even in a privacy respecting on a privacy L1 or L2, I can correlate the underlying transport information on the IP address level with what happens on chain. So even a perfectly private L1 needs this transport level privacy that we're building at HOPR. And if we're thinking about that today, because you asked how much better off would I be, well, do I want Infura to know all my accounts and link them together? I don't, right? And this is really tricky to solve today. I don't want any of the RPC providers that we have out there to identify all my accounts, some of which may or may not be anons, right? So we want to keep that stuff private.
Okay, but you could in principle keep that private by connecting to your own dApp node or a friend's dApp node or something similar, right?
So ideally, that is indeed the case, right? I have a dApp node, but on my mobile wallet, I'm not always carrying my dApp node on my back. So then it already gets a little bit tricky, right? And in that case, your mobile internet service provider can link all that data. Kind of going forward, the second layer where I see privacy issues is not just on the wallet side, but also between the nodes itself. So one project we recently were digging into is the privacy of proof of stake beacon chains. So Ethereum beacon chain or Gnosis beacon chain, and also on that side we don't have privacy. So I find it kind of funny how even the most anon people on Twitter are, posting who is their, which one is their validator node. Because we have, for example, right now on the Gnosis beacon chain, kind of a data harvesting node running, which is collecting all attestations. And I can find out your IP address from that, right? And if you run that on a dApp node out of your own home, then I can find out where you run that, and I can launch a highly targeted attack against you, which is kind of problematic. So also on that side, I argue we need to talk about privacy much more seriously than we do today if we do not want to see some really weird level of attacks against the infrastructure.
Yeah, that is a very valid point. Maybe, so basically HOPR runs on Gnosis chain / Ethereum. Seeing that you're kind of stripping the metadata, and we already talked about how on there are privacy preserving layer ones already. Why didn't you launch HOPR? I mean, not that I don't like having your Gnosis chain, don't get me wrong, but why didn't you launch on an inherently privacy preserving chain like Zcash or Monero, where basically stripping metadata would be a much larger value add, seeing that all of the data is already protected?
Yeah, that's a great question. Well, the simple answer is if there would be a private, like ultimately private L1 or L2, like very happy to go there, but there is no such thing around today. So at HOPR, we need some on-chain cryptographic primitives that allow us to implement this proof of relay mechanism. So that's the key sharing mechanism that I explained before, which is not possible to be built with these simplistic privacy L1s, like privacy coins like, Monero or Zcash. But ultimately, that is where I see this going, that there's a private L1 that uses that. One thing that's important to highlight, though, is HOPR runs on some chain. Currently, it's Gnosis chain. But you could use HOPR to connect your wallet to an RPC provider on any chain. You could use that for private Bitcoin transactions. And this is something that people are sometimes confused by. HOPR, on the one hand, uses a chain for the incentives of the mixed node operators. But using HOPR, you can use for anything, any chain out there, including, Bitcoin, if you so choose.
Yeah, that makes tons of sense. Maybe zooming out a little. If you look at privacy systems in crypto and actually in the larger world, there are quite a number of them. And somehow they don't end up very successful, or nowhere near as successful as really they should be. Why do you think there is this apathy towards privacy preservation?
Yeah, so first of all, I agree there, right? And while there might be some specific reasons why some of these systems were not so successful, ultimately it's hard to have a startup that executes well. I would say the more overarching, larger reason is that in crypto generally, people have for too long been too high on making too much money too quickly. And why would you need privacy, right? If I can just DeFi summer has been great to many people here, and it's been great, right? But we only start seeing that the underpinning value of all of crypto, at least in my mind, is not just to make more money quicker than we can today, but to have these ultimately resilient foundations on which we can build everything else. And that's something that the past weeks have in a very dramatic way shown, right? The Tornado Cash sanctions have shown for the first time that we are headed for this inevitable battle between today's power structure of the established world and all of this crypto craziness. And I don't even mean the regulators. I mean really the people who have a lot to lose if we're changing the entire system on which commerce in the world is being run. And I am really absolutely convinced that if and when, not if, but when that happens, we need strong privacy to protect the values that we're running for. It's just that so far we have been making incremental steps and had all great parties making money. But, this looming showdown between the power structures of today's world and crypto has only, barely begun. When that does happen, we better do have privacy infrastructure in place that is strong enough.
Yeah, but I think Friederike's question is, it's so in my experience, right? The nature of crypto is that the crowd can speculate on anything and raise the value of anything it so chooses and make money like that with it, right? Like IOTA is the perfect example, right? When the crowd wants to do it, the crowd can do it, and that there are lots of different examples like that in crypto. But it's also concurrently with that, it's like in the 8 or 9 years I've been in this field, I've seen like generations of privacy projects come, right? Like a Monero. And then I've seen like Monero slowly and slowly getting eroded in the market, right? Like falling, falling, falling. And now it's like something like number 30. Zcash, I think a lot like a similar story. Um, and to me, what feels really odd is on the one side, if you see like the crypto rhetoric, it's all about privacy conscious infrastructure, privacy conscious. But the market action is not like that, and in reality, it's like in crypto, speculators can make or break a coin any day, independent of fundamentals, right? So it still feels like privacy doesn't take off as a bigger theme, or like struggles as a bigger theme in comparison to something else like smart contract chains or L2 chains. Like if you see the L2 chain world, well, it's taking off very naturally, even without a lot of fundamentals. You launch a new L2 chain, it's going to have a huge market cap. So that theme succeeds massively, but the privacy theme doesn't sort of succeed a lot. Whereas like the crypto rhetoric is about privacy. Do you feel this the same way, or is it me just that feels like this?
So I see that obviously, there's no point in denying that, but I'm obviously willing to take the different bet here. So I would say now, and that is different to a few years ago, shots have been fired, right? And there's currently a brilliant coder who is currently in jail for writing privacy software that helps the betterment of the entire space. So, we had what I would call regulatory overstepping. That is the first out of what I think is going to be many shots that will be fired against all of crypto and all of Web3, because what this is all about is about challenging the power structures of today's world. And it will only get worse from here. And the only thing that can really sustainably improve the whole thing is strong privacy. It's not going to be regulations. Like the Web3 is anarchy. And anarchy goes both ways. There is no regulations that can protect the people or, any of the bigger structures. So the only thing that can help us here is strong privacy across the full stack. And that's why I think now, maybe more than 5 years ago, is the right time for privacy. And, I wish there were more of these projects that successfully are bringing that privacy to the whole stack.
And I had another question. Have you or has Hopper ever been contacted by a 3-letter agency?
We have not. I would say Hopper is so far doing well, flying under the radar. So far we're out of there, but maybe that changes with the level of production readiness. Like one thing that I'm kind of happy about is to not work on a on-chain privacy. So Hopper does not do any coin mixing, right? To some of the 3-letter agencies who do listen to Epicenter, like we have seen evidence of that, right? So Hopper is not a mixer. Hopper is only for private data, which I think is important for everyone in the space. And ultimately, maybe just to put that also out there, regulators have the task to protect the people. That is the mission of Hopper and a lot of Web3 also, right? Empowerment of the people is, I would say, the overarching theme of all of the Web3 movement. That's what we want to achieve. So I don't think we're fundamentally at odds with regulators. We're fundamentally at odds with power structures that want to retain power.
This is kind of a little bit of a segue, but bear with me. So in Balaji's book, he talks about how Twitter bios are the perfect way of kind of analyzing the perceived identity of people. So basically how people describe themselves in their Twitter bios is actually really interesting. I've paid a lot of attention to this hence. And Ed Snowden's Twitter bio says, "I used to work for the state, now I work for the people." So do you think, Sebastian, so basically you kind of conflated the two a second ago, right? So basically you assume that the state works for the people also.
Well, I mean, there's certainly some power structures within the state that do not work for the people. But I was talking about the regulator itself, which has a specific mandate, which, at least in Europe, has been many times shown to protect the people from, for example, powerful structures in North America that are data harvesting and going against the people. But that being said, ultimately, I believe in the good in people. Right. So ultimately, I do believe in people wanting to do innovation for good. I do believe that people want to build great things. We have to just let them more. And unleashing that power in a safe way is what I'm after. And again, I don't think that's fundamentally at odds with any good states or regulators out there.
I would hope so. So HOPR relies on the fact that many people run nodes, right? Even if the requirements on any particular node is not particularly high, you need to have more than, say, 5 nodes in order to kind of run a mixing network, right? So how can people become a part of HOPR?
Yeah, so there is at least 2 or 3 sides to it. So first of all is you can build on top of HOPR. So check out what's been built and apply for bounties. We're also busy at hackathons where you can build stuff because it's not just the people running the infrastructure, it's also people, building stuff with that infrastructure and using it. So using it is the second part. Check out what other people have already been built. You don't need to install complicated stuff. Just check out the HOPR playground. And the third thing is indeed, as you say, to run a node. If you want to run a node, initially, as I mentioned before, we have restricted the size of the number of mixed nodes to currently 100. If you want to run a node, check out our website. So we will have the next network launch in 2 weeks from now. So at that point, you can run a node and find all the instructions on our website. And contribute to data privacy for others.
Thank you, Sebastian, for coming on. That was super elucidating, if somewhat apocalyptic in its outlook. So I like you feel that there might be more regulatory action coming, and I fear we're also making it too easy for 3-letter agencies to shut down certain functions of Web3 because we're not committed enough to decentralization and credible neutrality, which kind of go hand in hand, right? So basically, if you have 5 big node operators, that's 5 people you have to call.
Exactly. Yeah. The last thing I would want to add to that one is just a thought that, I find sometimes people being surprised by. And that is, if we don't take privacy seriously, this whole Web3 vision is going to bring us to a world that is worse than today's Web 2.0. And that is because the data harvesting crooks of the Web 2.0, they're not just going to go away. They will see our world and they will say, anarchy? Well, anarchy is great because the rules and regulations that constrain me in today's Web 2.0, they don't apply here anymore. I can use that. I can use that against people, with what you call today MEV. I'm fine calling it that way. I'm a professional data harvester. So again, to prevent that from happening and have the Web3 be a safe place, we do need privacy across the stack.
Absolutely.
Thanks, Friederike, for having me on. Thanks, Meher, for this great show.